Spray painting Arlington connectors may impact their grounding effectiveness and create electrical code violations if the paint blocks or obscures the bonding strip. The bonding strip on Arlington connectors establishes grounding between the connector and the raceway. If the paint seals this strip, it could compromise the grounding path. Thick or non-conductive paint can create resistance between the connector and the raceway, reducing the effectiveness of the grounding path. Spray paint can damage the metal housing or terminals of the connector, compromising its integrity and grounding ability. To avoid potential electrical hazards and code violations, it is recommended to not spray paint Arlington connectors. Instead, consider alternative methods to achieve the desired color coding. Firstly, use colored electrical tape by wrapping colored electrical tape around the cable or connector near the Arlington connector to indicate the desired color code. Secondly, use colored heat shrink tubing by shrinking colored heat shrink tubing over the cable or connector before installing the Arlington connector. And thirdly, use color-coded cable by pre-ordering MZ cable with color jackets to match the desired color code. If you absolutely must spray paint the connectors, test them for proper grounding after painting. Use a multimeter to ensure that there is continuity between the raceway and the connector housing. Use thin, conductive paint, choosing spray paint that is specifically designed for electrical applications and has low resistance. Apply the paint sparingly and avoid applying thick layers of paint that could block the bonding strip or damage the connector. It is important to understand the purpose of the bonding strip in maintaining a safe and effective ground. The bonding strip is a critical component of the grounding system, providing a low impedance path for fault current to return to the source. This low impedance path helps to ensure that overcurrent devices, such as circuit breakers or fuses, will trip quickly in the event of a ground fault, minimizing the risk of electrical shock or fire. When paint is applied to the connector, several potential problems can arise. Firstly, the paint can act as an insulator, preventing the bonding strip from making good electrical contact with the raceway. This can increase the impedance of the grounding path, making it less effective. Secondly, some paints can be corrosive, damaging the metal of the connector or the bonding strip over time. This can further reduce the effectiveness of the grounding system. Thirdly, thick layers of paint can physically block the bonding strip, preventing it from making contact with the raceway altogether. This is especially problematic if the paint is applied to the threads of the connector, as this can prevent the connector from being properly tightened. In addition to the potential for grounding problems, spray painting connectors can also create code violations. The National Electrical Code, or NEC, sets strict requirements for the grounding of electrical systems. These requirements are designed to ensure that electrical systems are safe and reliable. Spray painting connectors can violate these requirements in several ways. Firstly, the NEC requires that all grounding connections be clean and free of paint, corrosion, and other foreign materials. Spray painting connectors can violate this requirement by coating the grounding connections with paint. Secondly, the NEC requires that all grounding connections be made with approved connectors and fittings. Spray painting connectors can violate this requirement by altering the connectors in a way that is not approved. Thirdly, the NEC requires that all grounding connections be properly tightened. Spray painting connectors can violate this requirement by preventing the connectors from being properly tightened. Because of these potential problems, it is generally recommended to avoid spray painting Arlington connectors. If you must spray paint the connectors, it is important to take steps to minimize the risk of grounding problems or code violations. This includes using thin, conductive paint, applying the paint sparingly, and testing the connectors for proper grounding after painting. It is also important to consult with a qualified electrician to ensure that the installation complies with all applicable codes and regulations. There are several alternative methods that can be used to achieve the desired color coding without spray painting the connectors. These include firstly colored electrical tape, which is a simple and effective way to identify different circuits or conductors. Electrical tape is available in a variety of colors, and it can be easily applied to the cable or connector near the Arlington connector. Secondly, colored heat shrink tubing, which is another good option for color coding. Heat shrink tubing is available in a variety of colors and sizes, and it can be shrunk over the cable or connector to provide a permanent color code. And thirdly, pre-colored cable, which is the most professional way to color code electrical wiring. Pre-colored cable is available in a variety of colors, and it can be ordered to match the desired color code. By using one of these alternative methods, you can avoid the potential problems associated with spray painting Arlington connectors and ensure that the electrical installation is safe and code compliant. When selecting a spray paint for electrical applications, it is important to choose a product that is specifically designed for this purpose. These paints are typically formulated with conductive materials that help to maintain a good electrical connection. They are also resistant to corrosion and chemicals, which can help to protect the connector from damage. It is also important to choose a paint that is compatible with the material of the connector. Some paints can damage certain types of metal or plastic. Always read the manufacturer's instructions carefully before applying any spray paint to an electrical connector. When testing connectors for proper grounding after painting, a multimeter can be used. A multimeter is a versatile tool that can be used to measure voltage, current, and resistance. To test a connector for proper grounding, set the multimeter to the resistance setting and connect the probes to the raceway and the connector housing. The resistance reading should be very low, ideally less than 1 ohm. A high resistance reading indicates that there is a poor electrical connection between the raceway and the connector housing. If you find a high resistance reading, try cleaning the connector and the raceway with a wire brush. You may also need to tighten the connector. If the resistance reading remains high after cleaning and tightening the connector, you may need to replace the connector. By following these recommendations, you can minimize the risk of grounding problems or code violations when spray painting Arlington connectors. However, it is always best to avoid spray painting connectors if possible. Using alternative methods such as colored electrical tape, colored heat shrink tubing, or pre-colored cable is a safer and more reliable way to achieve the desired color coding. In addition to the technical aspects of grounding and color coding, it is also important to consider the overall safety of the electrical installation. Always follow all applicable codes and regulations, and always consult with a qualified electrician if you have any questions or concerns. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. Remember that the goal is to create a safe and reliable electrical system that will provide years of trouble-free service. By paying attention to the details and following best practices, you can achieve this goal. Also, remember that the NEC, which is updated every 3 years, serves as the cornerstone for safe electrical installations in the United States. It provides comprehensive standards for electrical wiring, overcurrent protection, grounding, and equipment. When considering the prefabrication of electrical systems, the NEC offers guidance on maintaining safety and code compliance. The NEC addresses the use of listed or labeled equipment, which is relevant to prefabricating MC cable assemblies with Arlington connectors. Equipment that has been evaluated by a recognized testing laboratory and bears a listing mark indicates it meets established safety standards. When prefabricating assemblies, ensuring that all components used are appropriately listed or labeled is crucial. The NEC outlines requirements for proper grounding and bonding, which are essential for electrical safety. These requirements aim to create a low impedance path for fault currents, minimizing the risk of electric shock and fire hazards. When prefabricating MC cable assemblies, it's vital to maintain the integrity of the grounding path throughout the assembly. Making proper connections and avoiding practices that could compromise grounding effectiveness are critical. The NEC addresses conductor identification and color coding to help ensure proper wiring and reduce the risk of errors during installation. When prefabricating MC cable assemblies, adhering to the NEC color coding requirements is essential for maintaining consistency and safety. The NEC provides guidance on cable installation methods, including support, securing, and protection from physical damage. When prefabricating MC cable assemblies, it's important to consider how these assemblies will be installed in the field and to ensure that they meet the NEC requirements for proper support and protection. The NEC includes requirements for electrical connections, including splicing and termination. These requirements aim to ensure that connections are mechanically and electrically sound, reducing the risk of loose connections, overheating, and arcing faults. When prefabricating MC cable assemblies with Arlington connectors, it's crucial to make sure that all connections are made properly and in accordance with the NEC requirements. The NEC contains requirements for overcurrent protection, including circuit breakers and fuses. These devices are designed to protect electrical circuits from overloads and short circuits. When prefabricating MC cable assemblies, it's important to select the appropriate overcurrent protection for the intended application and to ensure that the assembly is properly protected. The NEC provides guidelines for working safely with electricity, including lockout/tagout procedures, personal protective equipment, and safe work practices. When prefabricating MC cable assemblies, it's essential to follow these guidelines to protect workers from electrical hazards. Firstly, it is essential to use properly rated and listed components to avoid compromising the safety and performance of the electrical system. Secondly, it is necessary to maintain the integrity of the grounding path to minimize the risk of electrical shock and fire hazards. Thirdly, it is vital to adhere to color coding conventions to ensure proper wiring and reduce the risk of errors during installation. Fourthly, it is crucial to install cable and raceway systems correctly to provide adequate support and protection for conductors. Fifthly, it is important to make proper electrical connections to minimize the risk of loose connections, overheating, and arcing faults. Sixthly, it is critical to provide adequate overcurrent protection to protect electrical circuits from overloads and short circuits. Seventhly, it is necessary to follow safe work practices to protect workers from electrical hazards. When designing a prefabrication system for a high-rise condominium complex, the use of MC cable with pre-attached Arlington connectors offers several potential advantages. One such advantage is that prefabrication can significantly reduce on-site labor costs. By assembling components in a controlled environment, the amount of time and effort required for installation in the field can be minimized. This can be especially beneficial in high-rise construction projects, where labor costs can be a significant factor. Another advantage is that prefabrication can improve the quality of the electrical installation. In a controlled environment, it is easier to ensure that all connections are made properly and that all components are installed correctly. This can lead to a more reliable and safer electrical system. Prefabrication can also reduce the amount of waste generated on site. By precisely cutting and assembling components in a controlled environment, the amount of scrap material can be minimized. This can save money and reduce the environmental impact of the construction project. Prefabrication can also improve the overall schedule of the construction project. By assembling components off-site, the amount of time required for on-site installation can be reduced. This can help to accelerate the construction schedule and bring the project to completion sooner. However, there are also some challenges associated with prefabrication. One challenge is that it requires careful planning and coordination. All components must be accurately measured and assembled in the correct sequence. This requires close communication between the design team, the prefabrication facility, and the on-site installation crew. Another challenge is that prefabrication can be difficult to modify once the components have been assembled. If changes are required in the field, it may be necessary to disassemble the prefabricated components and reassemble them to meet the new requirements. This can add time and cost to the project. Despite these challenges, prefabrication can be a valuable tool for high-rise construction projects. By carefully planning and coordinating the prefabrication process, it is possible to realize significant cost savings, quality improvements, and schedule reductions. However, it is important to remember that prefabrication is not a substitute for good electrical design and installation practices. All electrical work must be performed in accordance with applicable codes and regulations, and all electrical components must be properly installed and maintained. If you are considering prefabrication for a high-rise condominium complex, it is recommended that you consult with a qualified electrical engineer and a reputable prefabrication facility. These professionals can help you to assess the feasibility of prefabrication for your project and to develop a plan that will meet your specific needs. With careful planning and execution, prefabrication can be a valuable tool for creating a safe, reliable, and cost-effective electrical system for your high-rise condominium complex. The importance of proper grounding is critical in electrical systems for several reasons. Proper grounding ensures electrical safety by providing a low-resistance path for fault currents to flow back to the source. This helps to quickly trip over current protection devices such as circuit breakers or fuses, which disconnect the power and prevent electrical shocks or fires. Proper grounding also helps to minimize voltage fluctuations and electrical noise in the system. This can improve the performance of sensitive electronic equipment and prevent malfunctions. Proper grounding protects equipment from damage caused by lightning strikes or other transient voltage surges. A well-grounded system provides a path for these surges to dissipate harmlessly into the earth. Proper grounding complies with electrical codes and standards such as the NEC, which are designed to ensure the safety and reliability of electrical installations. Improper grounding can have serious consequences, including electrical shocks, fires, equipment damage, and code violations. Therefore, it is essential to ensure that all electrical systems are properly grounded. There are several different methods of grounding electrical systems, including equipment grounding, system grounding, and bonding. Equipment grounding involves connecting the non-current carrying metal parts of electrical equipment, such as enclosures and raceways, to a grounding electrode. This provides a low resistance path for fault currents to flow back to the source. System grounding involves connecting the neutral conductor of an electrical system to a grounding electrode. This helps to stabilize the voltage of the system and prevent voltage fluctuations. Bonding involves connecting together all of the metal parts of an electrical system, including equipment enclosures, raceways, and grounding electrodes. This creates a common ground reference point and helps to minimize voltage differences between different parts of the system. Choice of grounding method depends on the specific application and the requirements of the electrical code. In general, it is best to use a combination of grounding methods to provide the most comprehensive protection. It is important to note that grounding is not the same as bonding. Grounding provides a path for fault currents to flow back to the source, while bonding creates a common ground reference point. Both grounding and bonding are essential for electrical safety. To properly ground an electrical system, you must first identify the grounding electrode. The grounding electrode is typically a metal rod or plate that is buried in the earth. The grounding electrode must be made of a conductive material such as copper or galvanized steel. The grounding electrode must be of sufficient size to carry the expected fault current. The grounding electrode must be properly installed in accordance with the electrical code. Once you have identified the grounding electrode, you must connect it to the electrical system. This is typically done by running a grounding conductor from the grounding electrode to the main electrical panel. The grounding conductor must be of sufficient size to carry the expected fault current. The grounding conductor must be properly installed in accordance with the electrical code. In addition to the grounding electrode and the grounding conductor, you may also need to install bonding jumpers. Bonding jumpers are used to connect together all of the metal parts of the electrical system, including equipment enclosures, raceways, and grounding electrodes. Bonding jumpers must be of sufficient size to carry the expected fault current. Bonding jumpers must be properly installed in accordance with the electrical code. Once you have properly grounded and bonded the electrical system, you must test it to ensure that it is working correctly. This is typically done by using a ground resistance tester. A ground resistance tester measures the resistance between the grounding electrode and the electrical system. The resistance should be very low, typically less than 25 ohms. If the resistance is too high, it indicates that there is a problem with the grounding system. If you find a problem with the grounding system, you must correct it immediately. A properly grounded and bonded electrical system is essential for electrical safety. Therefore, it is important to take the time to ensure that the grounding system is working correctly. There are several common mistakes that people make when grounding electrical systems. One common mistake is to use undersized grounding conductors. Undersized grounding conductors cannot carry the expected fault current, which can lead to electrical shocks or fires. Another common mistake is to improperly install grounding electrodes. Improperly installed grounding electrodes may not provide a good connection to the earth, which can reduce the effectiveness of the grounding system. Another common mistake is to fail to bond all of the metal parts of the electrical system together. Failing to bond all of the metal parts of the electrical system together can create voltage differences between different parts of the system, which can lead to electrical shocks. Another common mistake is to neglect to test the grounding system after it has been installed. Neglecting to test the grounding system after it has been installed can leave undetected problems that can lead to electrical shocks or fires. By avoiding these common mistakes, you can ensure that your electrical system is properly grounded and safe. There are several resources available to help you learn more about grounding electrical systems. The NEC is a comprehensive resource that provides detailed information on grounding requirements. There are also many online resources available, such as websites and forums, that can provide helpful information on grounding electrical systems. In addition, there are many qualified electricians who can provide professional guidance on grounding electrical systems. By taking the time to learn more about grounding electrical systems, you can help to ensure the safety of your home or business. The type of paint used is also important to consider. Standard paints are typically non-conductive and can interfere with the grounding path. If painting is unavoidable, use a specialized conductive paint designed for electrical applications. These paints contain metallic particles that allow electricity to flow through them, maintaining the grounding connection. However, even with conductive paint, apply it sparingly to avoid creating a thick layer that could still impede conductivity. Another option is to use a clear coating that protects the metal from corrosion without affecting its conductivity. When applying any coating to electrical connectors, it is crucial to ensure that the surfaces are clean and free from dirt, grease, or rust. These contaminants can interfere with the grounding connection and reduce the effectiveness of the coating. Use a wire brush or sandpaper to clean the surfaces thoroughly before applying the coating. Proper surface preparation is essential for ensuring a good electrical connection and preventing corrosion. After applying the coating, allow it to dry completely before installing the connector. This will prevent the coating from smearing or interfering with the grounding connection. Follow the manufacturer's instructions for drying time and temperature. Proper drying is essential for ensuring that the coating provides adequate protection and does not interfere with the electrical connection. Before installing the connector, inspect it carefully to ensure that the coating has not damaged the connector or its components. Check for cracks, chips, or other signs of damage. If you find any damage, replace the connector immediately. Damaged connectors can compromise the grounding connection and create a safety hazard. When installing the connector, tighten it securely to ensure a good electrical connection. Use a torque wrench to tighten the connector to the manufacturer's specified torque. Over-tightening or under-tightening the connector can damage the connector or reduce the effectiveness of the grounding connection. After installing the connector, test the grounding connection to ensure that it is working properly. Use a multimeter to measure the resistance between the connector and the grounding point. The resistance should be very low, typically less than 1 ohm. A high resistance reading indicates that there is a problem with the grounding connection. If you find a high resistance reading, check the connector for damage, ensure that the surfaces are clean and free from contaminants, and tighten the connector securely. If the problem persists, replace the connector. Regular inspection and testing of electrical connectors are essential for ensuring that they are working properly and that the grounding connection is intact. Inspect the connectors regularly for damage, corrosion, or loose connections. Test the grounding connection periodically to ensure that it is still working properly. By following these tips, you can help to ensure that your electrical connectors are properly coated and that the grounding connection is maintained. This will help to protect your electrical system and prevent electrical shocks or fires. When considering the use of MC cable in a prefabrication system for a high-rise condominium complex, it's important to consider several factors. MC cable, or metal-clad cable, is a type of electrical cable that consists of insulated conductors encased in a metallic sheath. This sheath provides mechanical protection for the conductors and also serves as a grounding path. NC cable is commonly used in commercial and industrial buildings, as well as in residential applications. One of the main advantages of MC cable is its flexibility and ease of installation. The metallic sheath protects the conductors from damage, allowing the cable to be run in exposed locations without the need for conduit. MC cable is also relatively easy to cut and terminate, making it a popular choice for electrical contractors. Another advantage of MC cable is its fire resistance. The metallic sheath helps to contain fires and prevent them from spreading, making MC cable a safer option than non-metallic cables. MC cable is also resistant to moisture and chemicals, making it suitable for use in a variety of environments. When using MC cable in a prefabrication system, it's important to select the appropriate type and size of cable for the application. The size of the cable will depend on the ampacity requirements of the circuit, while the type of cable will depend on the environmental conditions and the specific requirements of the electrical code. It's also important to use approved connectors and fittings for terminating MC cable. These connectors and fittings must be properly installed to ensure a secure and reliable electrical connection. When prefabricating MC cable assemblies, it's important to follow all applicable codes and regulations, including the NEC. This will help to ensure that the electrical installation is safe and code compliant. It's also important to test the MC cable assemblies before installation to verify that they are properly grounded and that all connections are secure. This can help to prevent problems and ensure the reliability of the electrical system. In addition to the technical aspects of using MC cable, it's also important to consider the cost. MC cable is typically more expensive than non-metallic cables, but the added benefits of mechanical protection and fire resistance may justify the higher cost. When comparing the cost of MC cable to other wiring methods, it's important to consider the total installed cost, including the cost of materials, labor, and any necessary conduit or fittings. The specific type of MC cable should align with the needs for the project. Aluminum interlocked armor, or AA, MC cable is a lightweight option suitable for general use, while steel interlocked armor, or SHA, MC cable provides enhanced durability and protection. Corrugated metal clad, or CMC, cable is flexible and suitable for tight spaces. MC cable is available with various conductor types, including copper and aluminum. Copper conductors offer high conductivity and corrosion resistance but are more expensive than aluminum conductors. The choice of conductor material should be based on the specific requirements of the application. MC cable is available in a range of sizes to accommodate different ampacity requirements. The appropriate size of MC cable should be selected based on the load calculations for the circuit. Using the correct size of MC cable ensures that the circuit can safely carry the required current without overheating. The length of MC cable run should be carefully planned to minimize voltage drop and ensure efficient power delivery. Long cable runs can result in significant voltage drop, which can affect the performance of electrical equipment. Voltage drop calculations should be performed to determine the appropriate cable size and length for each circuit. The grounding requirements for MC cable are outlined in the NEC. The metal sheath of the MC cable serves as the equipment grounding conductor and must be properly connected to the grounding system. Approved connectors and fittings must be used to terminate MC cable and ensure a secure and reliable electrical connection. Proper termination of MC cable is essential for maintaining the integrity of the grounding path and preventing electrical hazards. The NEC specifies the requirements for supporting and securing MC cable. MC cable must be properly supported to prevent it from sagging or being damaged. Approved cable ties, straps, or clamps should be used to secure MC cable to building structures. MC cable should be protected from physical damage to prevent damage to the conductors and maintain the integrity of the grounding path. The NEC specifies the requirements for protecting MC cable from physical damage in areas where it is exposed to mechanical hazards. MC cable should be installed in accordance with the manufacturer's instructions and all applicable codes and regulations. Following the manufacturer's instructions ensures that the MC cable is installed correctly and performs as intended. Prefabricating MC cable assemblies can help to reduce on-site labor costs and improve the efficiency of electrical installations. Prefabrication involves assembling MC cable assemblies off-site in a controlled environment. Prefabricated MC cable assemblies can be customized to meet the specific needs of the project. This can help to streamline the installation process and reduce the amount of time required for on-site wiring. MC cable is a versatile and reliable wiring method that can be used in a variety of applications. However, it is important to select the appropriate type and size of MC cable for the application and to follow all applicable codes and regulations. By following these guidelines, you can ensure that the electrical installation is safe, code compliant, and efficient. If the design incorporates a color code system that requires something on the prefabricated product to be color spray painted, consideration should be given to the grounding effectiveness and potential electrical code violations. Using colored electrical tape, heat shrink tubing, or pre-colored cable are good alternative methods that can be utilized. MC cable offers a good balance of safety, durability, and ease of installation.